In 2024, while everyone was watching Tesla, a Chinese company quietly outsold them by more than double. Now that same company says its next-generation battery will charge fast enough to make petrol stations irrelevant. The company is BYD. The battery is the second-generation Blade. And what they're claiming isn't just ambitious. It breaks the rules of what we thought lithium batteries could do. But here's the thing. I'm not going to hype you. I'm going to show you exactly what's real, what's possible, and what's still missing. Because the truth is more interesting than the hype. Here's what actually happened. BYD's chairman, Wang Tuanfu, has been signaling through press events and product launches that the next evolution of BYD's battery platform will dramatically cut charging times. BYD's newer models, built on their Super E platform, already use high-voltage 800-volt-plus architecture, and some are showing 10 to 80% charge in roughly 10 to 15 minutes under the right conditions. Now, let me be precise here because precision matters. They are not saying 0 to 100% in 5 minutes. Nobody credible is claiming that. What they are showing is that the usable range, the charge you actually need for your day, can be added in the time it takes to grab a coffee. And that distinction matters enormously, because in real life, you almost never charge from 0, and you rarely need a full battery. You need enough to get where you're going. If that takes 10 to 15 minutes, the psychology of owning an EV changes completely. That not yet that millions of people say when they consider an EV, it starts becoming, okay, maybe now. But before we dig into the technology, you need to understand why this company, and not Tesla, not Toyota, not Volkswagen, is the one making this claim. Because the backstory is the reason it's credible. BYD was founded in 1995 in Shenzhen, China. Not as a car company, as a battery manufacturer. They made rechargeable batteries for Nokia and Motorola phones. That's where they learned battery chemistry from the inside out. In 2003, they made a move nobody understood. They bought a small, struggling Chinese car company. The industry laughed. A battery company making cars? But BYD saw something others missed. They saw the car as a battery product first. Everything else, the seats, the screen, the body, was secondary to what powers it. In 2008, Warren Buffett's Berkshire Hathaway invested $230 million in BYD. That got the world's attention. Fast forward to 2024. BYD sold approximately 4.27 million new energy vehicles. That's fully electric plus plug-in hybrids combined. Tesla sold about 1.79 million pure electric vehicles. Now, those aren't perfectly apples-to-apples numbers, because BYD includes hybrids. But the scale is undeniable. BYD is the largest seller of electrified vehicles on the planet, and unlike most car companies, BYD makes its own batteries, its own motors, its own semiconductors. That vertical integration is why their costs are lower, and it's why their battery claims carry weight. They're not buying someone else's technology. They built it. So what exactly is the Blade battery, and why does it matter? The original Blade battery, introduced in 2020, uses lithium iron phosphate chemistry, LFP for short. Now here's why that's important. Most high-performance EV batteries use nickel-based chemistry. Nickel gives you more energy density, meaning more range per kilogram. But nickel-based batteries have a serious problem: thermal instability. They're more likely to overheat, more likely to catch fire. LFP chemistry is inherently more stable. It doesn't store quite as much energy per kilogram, but it handles heat far better. And BYD made a design choice that turned this trade-off into an advantage. The Blade battery is shaped like a long, thin blade, hence the name. These flat cells pack directly into the battery pack without modules in between. This does 3 things simultaneously. 1. More cells fit in the same space, compensating for LFP's lower energy density. 2. The flat shape spreads heat more evenly across the pack, reducing hot spots. 3. The structural design makes the pack part of the car's chassis, adding rigidity while saving weight. But the moment that made the Blade battery famous was the nail penetration test. BYD drove a steel nail through the middle of a fully charged Blade battery cell. In the same test, a standard nickel-based cell caught fire almost immediately. The Blade cell? No fire. No explosion. Surface temperature barely rose. For an ordinary person, this translates to one thing. In an accident, this battery is far less likely to become a danger to your family. The Blade battery also handles thousands of charge-discharge cycles without significant degradation. That's why you see BYD batteries in taxis and buses, vehicles that charge and discharge every single day for years. Safe, durable, affordable. That's the foundation. Now let's talk about what's being built on top of it. Here's where I need to be honest with you. BYD and Lech hasn't published a full technical white paper on the second-generation Blade battery and said here are all the specs. What we have are product launches, patent filings, platform announcements, and engineering signals. So I'm going to separate what's confirmed from what's projected. Confirmed. BYD's Super E platform uses 800-volt plus architecture. This is the electrical backbone that allows faster charging. Higher voltage means you can push the same energy with less current, which means less heat. Confirmed. Newer BYD models on this platform are demonstrating roughly 10 to 80% charge in about 10 to 15 minutes, with compatible DC fast chargers. Confirmed. BYD has improved the energy density of its LFP cells. The second-generation Blade cells are reported to exceed 190 watt-hours per kilogram at the cell level, up from around 150 in the first generation. Expected better thermal management inside the pack. This means more sophisticated cooling channels that distribute heat evenly during fast charging, preventing any single cell from overheating. Think of it this way. If you pour boiling water into a single thin glass, it cracks. But spread that same heat across a thick ceramic plate and it absorbs it safely. That's what advanced thermal management does for a battery. Expected. Tighter cell-to-pack integration. The cells are likely packed even more efficiently, with less wasted space, which means more energy in the same physical footprint. Expected. Improved cycle life under fast-charging conditions. First-gen Blade batteries could handle thousands of cycles at moderate charging speeds. The next generation likely maintains that durability even when charging at much higher power levels. But we don't know yet. Exact mass production timelines for the highest spec versions. We don't know final pricing across all markets. And we don't know how these batteries will perform over 5+ years in extreme climates. That data simply doesn't exist yet, because the technology is new. And I want you to hold on to that last point, because the most important thing about any battery claim isn't what it does on day 1. It's what it does on year 5. If you find this kind of honest breakdown valuable, consider subscribing. No hype, just real information. And it helps this video reach more people who want the truth about EV technology. Now, here's something most BYD videos won't tell you. BYD is not the only company working on fast-charging batteries. CATL, China's largest standalone battery manufacturer, has already launched its Shenzhen LFP battery, which claims to add 400 kilometers of range in 10 minutes of charging. Tesla is developing its 4680 cell format, which aims to reduce cost and improve energy density through a dry electrode manufacturing process. Toyota is investing heavily in solid-state batteries, a completely different chemistry that could leapfrog lithium-ion entirely, though they've been 5 years away for over a decade now. So why should you still pay attention to BYD specifically? Because BYD doesn't just make batteries, it makes the entire car. It controls the battery, the motor, the power electronics, the vehicle software, and the manufacturing process. This vertical integration means BYD can optimize every component to work together. KDL makes great batteries, but it sells them to other car companies that may or may not optimize their vehicles around them. Tesla designs great vehicles, but it's still scaling its own battery production and relies partly on suppliers. BYD controls the full stack, and in the EV industry, full stack control means faster iteration, lower costs, and tighter performance. That's not hype. That's a structural advantage. Now let me pump the brakes, appropriately, because there are real obstacles that no battery can solve on its own. Obstacle 1. Charging infrastructure. A battery can accept a charge in 12 minutes, but only if the charger can deliver enough power. Today, many public chargers operate at 50 kilowatts. Some newer ones hit 150 or 350 kilowatts. BYD's fastest charging capabilities need chargers at the higher end of that range. In China, ultra-fast charging stations are expanding rapidly. In Europe and North America, they're growing but still patchy. In India, Southeast Asia, Latin America, and Africa, they're rare. So the battery might be ready, but the world's electrical infrastructure often isn't. Obstacle 2. Grid capacity. If thousands of cars in one neighborhood start fast charging in the evening, the same time everyone turns on air conditioning and cooking appliances, the local grid can buckle. Fast charging at scale requires grid upgrades, smart charging scheduling, and in some cases, local energy storage at the station itself. Obstacle 3. Long-term degradation data. Fast charging stresses battery cells more than slow charging. Period. Every battery manufacturer knows this. The question is how much more, and whether the engineering can keep that stress within acceptable limits over 8 to 10 years. BYD's track record with the first-generation Blade battery in commercial fleets is encouraging. But the second generation at higher charging speeds, we need real-world data over real-world years. No lab test fully replicates a decade of use in Dubai heat or Norwegian cold. These aren't reasons to dismiss BYD. They're reasons to stay informed rather than just impressed. Let's set aside the corporate competition for a moment and talk about why any of this matters to a normal person thinking about their next car. Today, the number one reason people hesitate to buy an EV is not price, it's the fear of being stranded. Range anxiety, charging anxiety, the worry that you'll be stuck at a charging station for an hour while your kids are restless in the back seat. If practical charging time drops to 10 to 15 minutes, genuinely, reliably in the real world, that fear dissolves. And when fear dissolves, behavior changes. Suddenly, the family in Jakarta considers an EV for their first car. The taxi driver in Sao Paulo switches from diesel. The delivery company in Berlin electrifies its fleet. The retired couple in Melbourne takes a road trip in an electric SUV without mapping every charger along the route. This is the shift from EVs as an enthusiast choice to EVs as a default choice. And it creates pressure in every direction. Other car companies are forced to match, not with press releases, but with actual products. Governments accelerate charging infrastructure investment because demand is now real. Electricity providers upgrade grids because the load is coming whether they're ready or not, and prices drop. When BYD can build a safe, fast-charging EV for $15,000 to $20,000, which they're already approaching in the Chinese market, the economics become impossible for consumers to ignore. This doesn't happen overnight, but the tipping point gets closer every time the charging bar fills a little faster. Here's the part most people miss. BYD's endgame isn't cars. Cars are a vehicle, in every sense, for something larger. BYD is positioning itself as an energy company. The same Blade battery technology going into sedans and SUVs is also going into grid-scale energy storage systems. BYD is already one of the world's largest suppliers of utility-scale battery storage. Think about that. Solar panels generate electricity during the day. Wind turbines generate power when conditions are right. But demand peaks in the evening. Storage bridges that gap, and BYD makes the storage. They also make electric buses operating in over 70 countries. They make electric trucks. They build the Skyrail monorail system. They're even involved in battery recycling. This is not a car company with a battery division. This is a battery and energy company that also happens to make cars, and that framing changes everything because it means the next generation Blade battery isn't just a car part. It's infrastructure. It's the building block of how cities might power themselves in 20 years, whether BYD specifically dominates that future or not. The model they're demonstrating, integrated energy solutions from cell to city, that model is where the entire industry is heading. So here's the bottom line. BYD's next generation Blade battery isn't magic, and it isn't going to change the world overnight. But it represents something genuinely important. Safe, fast, affordable charging built by a company that controls every layer of the technology. The real disruption won't come with a bang. It will come when millions of ordinary people realize they no longer have a reason to say not yet. That moment is getting closer. If you want to stay ahead of these shifts, without the hype, without the clickbait, subscribe and turn on notifications. I cover what's real in EV and energy technology. And if this video gave you something worth thinking about, share it with someone who's on the fence about going electric. That's how this information reaches the people who need it.